Can you read that problem? If 500 gram of molten lead at 327 degrees Celsius is poured into a cavity in a large block of ice at 0 degrees Celsius, how much of the ice melts? Can you visualize what happens here? We have a molten lead at 327 degrees Celsius. That is the melting point of lead. So what is going to happen to that molten lead when it is poured into a cavity of ice? First of all, liquid lead at 327 degrees Celsius will become solid lead at the same temperature, liberating an amount of heat, mass times latent heat of fusion. Is that right? Latent heat of fusion of lead. And I think I've given it to you. LF, latent heat of fusion of lead, is this. And then lead, the solid lead at 327 degrees Celsius will lose its temperature to what temperature? To 0 degrees Celsius, the temperature of ice, liberating an amount of heat, mass times specific heat of lead, that is given here, times the change in temperature. The change in temperature is 327 minus 0. So you can see the total amount of heat lost by lead. Now where is all that heat going? All that heat lost by lead is now absorbed by some amount of ice to melt. So what all ice is doing is changing its state from solid to liquid. Is the temperature of ice changing? No. So if m kilograms of ice gets melted, the amount of heat absorbed will be m times latent heat of fusion of ice. You see? And you can now equate the two. The amount of heat lost by lead equal to the amount of heat gained by ice. Let's do that. Molten lead becomes solid lead at 327 degrees Celsius and then cools down to 0 degrees Celsius, giving up its heat. Then m kilograms of ice melts by absorbing all that heat given up by lead. Alright, let's start by looking at each stage. Stage 1, molten lead at 327 degrees Celsius becomes solid lead at 327. What is the amount of heat liberated? Q1 equal to mass times latent heat of fusion. Is that right? A change of state without a change of temperature. That is, mass is 0.5 kilogram, 500 gram, and the latent heat of fusion of lead is given as 2.47 times 10 to the 4, and that will be 1.235 times 10 to the 4 joules is given out during that stage. And on the diagram it is this. So all the lead is liquid on the right side and all the lead is solid on the left side, and the amount of heat given out is 1.235 times 10 to the 4 joules. What is the next stage? Lead at 327 cools down to 0 degrees Celsius. What is the amount of heat liberated during that stage? There is a change in temperature. The amount of heat liberated is mass times specific heat of lead times the change in temperature, mc delta theta. Mass of lead is 0.5 kilogram. Specific heat of lead is given as 130 joules per kilogram per Kelvin. And the change in temperature is 327 minus 0. That is 327 Kelvin. Let me remind you one more time. The temperature interval 327 degrees Celsius minus 0 degrees Celsius is 327 Kelvin. The temperature intervals in degrees Celsius and Kelvin are the same. And this will be 2.126 times 10 to the power 4 joules. Now, this is the stage when that much of energy is lost by lead. Now, what is the total heat lost by lead? Is Q1 plus Q2, that is 3.361 times 10 to the 4 joules. And now, all this heat loss is going to be absorbed by ice. Let's set up the equation for the heat absorbed by ice. Now, m kilograms, suppose m kilograms of ice melted using that heat. M kilogram of ice melts by absorbing all the heat given up by lead. Heat absorbed by m kilogram of ice to melt without changing its temperature is mass times latent heat of fusion. And that will be m kilogram times latent heat of fusion of ice is 3.34 times 10 to the power 5 joules per kilogram. And we will write it as 3.34 times 10 to the power 5 m. We need to find the value of m. So many joules. So don't confuse here. This is this many numbers times m. We need to find that m. Now, how do you find that m? This amount of heat absorbed by ice equal to this amount of heat liberated by lead. So we will equate the two. And this is the amount of heat absorbed by ice. I use the blue line for that. Now, heat lost by lead equal to heat absorbed by ice. Therefore, 3.361 times 10 to the 4 joules is the heat lost by lead, and that's equal to 3.34 times 10 to the 5 m joules that is absorbed by ice. Can you solve for m from here? M will be this number divided by this number, and that's equal to 0.1 kilogram. Only 100 gram of ice melts by using all that energy. Why is the amount so low? Because the latent heat of fusion of ice is a very large quantity. And that's the reason why on the surface of the earth there are large quantities of water in the frozen form. But you know, the global warming is actually doing a lot of damage to those ice peaks. Is that right? They are melting at a much faster rate. Alright, so we must take care to preserve our environment. Okay, let's do another problem.